Okay, welcome back. There are some atoms like hydrogen you've already seen. Doesn't care if it doesn't have 8. It can't. It can only hold 2 electrons because it's got a 1s electron and it only has room for 1 more electron in that s orbital. That's near 1 distance from the nucleus. So, are there other atoms, though, that can only have set numbers and less than 8? A difference from the octet rule? And the answer is yes. Usually they're the small atoms. If you recognize where these are from, here's the periodic table. Okay, hydrogen's an exception. Beryllium's an exception, which is down here. My drawing is horrible. So hydrogen, beryllium, and boron, which is over here. Okay, so notice they're the first 3 smallest atoms. Hydrogen only wants to have 2 electrons, but that's 1 stick. Okay, boron wants to have 4 electrons. That's 2 sticks, one here, one there. So that's the boron, wants to have that many. And the beryllium, sorry. The boron can only handle 3 sticks. Okay, that's there. Sometimes aluminum will be that way. So aluminum can be, but if you can get it to have 8, you can try. That's a better drawing. But usually the hydrogen, beryllium, and boron are all going to be smaller than is capable to hold on those extra electrons. Okay, so they can have less. Now, I'm going to do an example for you of each of these. Anything from the 3rd row or lower, if you're done with your drawing and you still have extra electrons, they can be thrown into the middle. So let's do 2 examples of those. I'm going to take these rules away and I'll just repeat them as we're talking about it. Let's take something like boron trifluoride. Okay, if I'm going to write these structures here, oops, come on. I'm going to write down the number of electrons they have. Boron's got 3. Fluorine each has 7 times 3 is 21. So I've got a total of 24 electrons that structure can have. Now I'm going to lay down the atoms with the fluorines on the outside because I only have 1 boron. And oddly enough, it's more close to the middle of the periodic table. Somehow that is a helpful thing. And I'm going to start with electrons between them. That's where 6 electrons have gone. That gives me 18 more electrons left. So I've got 6 out right now, and I'm going to go around the outside of these atoms. So it's going to be 6, 8, 10, 12, 14, 16, 18, 20, 22, 24. I'm finished. Every fluorine's got 8, and boron's only got 6. So you'd say, is that fine? Is that okay? Yes, boron is an exception. It can handle only having 6, and that is a fine structure to show. Okay, so that's one example of a compound there, boron trifluoride. Okay, I've got examples as well that are answers of those sheets. Now let's take another one here. How about when we have too many? We've already seen hydrogen was a great example, and usually it only has 1 stick, so that's fine. We've seen those. Let's take one where it has too many electrons, and you have to use more on it. Let's take xenon hexachloride. No, not hexa. Let's go with xenon dichloride. Okay. We're going to add up these atoms. The xenon's got 8. Chlorine each has 7, so that's a total of 14. Total of 22 electrons. Now, I'm going to lay down the atoms. The xenon must be in the middle because it's only 1. Chlorine's on the outside. I'm going to start by putting the electrons between them. There's 2, 4. Then I'm going to go around the outside to get everybody to have 8. 2, 4, 6, 8, 10, 12, 14, 16, 18, 20. Everybody's got 8 right now, but I still have 2 more electrons to put somewhere. So the rule is if you finish your structure and everybody's got a happy amount, an 8 amount or the 2 for hydrogen or 3 for boron or those kinds of things, and everybody's happy, then put the extra ones only on the center atom. They have to be from the 3rd row or lower to be able to accommodate these extras. So that would be where you put this extra set of electrons, okay? Finish out those problems that have examples like these, and then the answer's there too if you need to check them. Okay, thanks.